Good morning everyone, myself Vishagashi. Today I will tell you some information about characteristics X-rays and I will explain the origin of X-rays spectra. Okay, so let's start with the definition. What is characteristics X-ray spectrum? When the target voltage is increased above a certain minimum value, it may be 30 kV for molybdenum. The continuous X-ray spectrum is found to be superimposed by sharp peaks of very high intensities and of definite wavelength as shown in figure. The X-rays corresponding to this wavelengths are known as characteristics of X-rays. The longer wavelength line is shown as a K alpha line and the shorter wavelength line is known as K beta line. जैसे हम डायग्राम में देख रहे हैं कि जो बड़ी शॉर्टर वेवलेंथ लाइन है वो K बीटा लाइन है और जो हाईएस्ट लॉन्गर वेवलेंथ है वो K अल्फा लाइन है. The wavelength of these characteristics X-rays do not depend upon the applied voltage V but depend on the material of the target. As the wavelength is the characteristics of target element, it is known as characteristic X-ray spectrum. Now let's start with the origin of X-rays spectrum. When a target atom is bombarded by fast-moving electrons, the incident electron penetrates inside the target atom through the outer shell and removes one atom of the electron from the innermost K shell. Under such a condition, the vacancy so created in the innermost K shell of a target atom is filled by another electron from the higher shell. We can say in this case we can say L shell. In this transition, electron from L shell jumps into the K shell to fill the vacancy, which results in the emission of photon. So what happened here? Higher energy electron bombarded on a target. Electron from the innermost K shell is removed. After that, electron jumps from L shell to K shell, and at this time emission of X-rays photon. The energy of the emitted photon will be equal to difference in energy of electron between the two shells. These are the photons which give rise to characteristics X-rays. The frequencies of the emitted X-ray photon is given by energy of K level shell minus energy of L level shell is equal to h mu alpha. Therefore, mu alpha is frequency of alpha line as a greater wavelength means longer wavelength. Mu alpha is equal to energy of K shell minus energy of L shell upon h. H is a Planck's constant here, where Ek is energy required to remove an electron from K level and El is the energy required to remove an electron from L level. Thus, if the frequency of the innermost K shell is filled by an electron from L shell, then K alpha line is produced. This is shown in figure. Now, if the vacancy of K shell is filled by transfer of an electron from M shell, then K beta line is produced and the frequency of emitted X-ray photon is given by energy of K level minus energy of M level shell is equal to h mu beta. However, mu beta is frequency is equal to Ek minus Em upon h. Thus, the jump of electron from various outer shells L, M, N, etc. of the atom to the K shell constitute the K series of X-ray spectrum. Similarly, if an incident electron carries lesser amount of energy, then it will remove an electron from L shell. Now this vacancy in L shell is filled from M or other outer levels, giving L series. This L series of the X-ray spectrum consists of L beta, L alpha, etc. lines due to the jump of electrons from various outer shells M, N, O of the atom to the L shell. Similarly, M series and N series are obtained.